This one says 4 consecutive odd integers sums to 80. And so we wrote down these in order to make use of them. And so on the test, you would get 2 points for that equation. We then solve it. You notice we have a total of 8 x's. And we have 1 and 3, which makes 4. 5 is 9. 7 is 16. Is equal to 80. And we solve. We subtract that 16. 8x is equal to 64. We divide by 8. We get x is equal to 8. So is that my answer?
Yeah.
No, it says find 4 consecutive integers.
Odd integers, right?
Then you
First of all,
plug in x to.
yeah, so this is the portion that represents how we find the solution. 2 times 8 is 16, plus 1 is 17, and then 19, and then 21, and 23. Those are the 4 consecutive odd integers. So again, if you find 17, 19, 21, 23, I'll give you a point. But having an equation that models it and finding x, that's where you get your second, third, and fourth point. So I need to see those. So simply just a guess and check. We're not gonna do that. Okay. Example 2: find 2 consecutive squares whose sum is 613. One of the best strategies that you can have as a mathematician is to. I had a professor in college, and he did give one piece of good advice. He said, if you don't know how to do the problem, just do the problem. And I know that sounds really silly, but we're going to employ that method here. It says find 2 consecutive squares whose sum is 613. So let's just think about it without the 613 for a second. What are 2 consecutive squares?
2 squared, 3 squared.
Sure, 2 squared, which is 4, and 3 squared, sorry, cancel. And then 3 squared, which is 9, right? Or say 10 squared, which is 100, and 11 squared, which is 121. Everybody good with that? Yeah. And then we're adding them up, okay? So 4 plus 9 is not 613. 100 plus 121 is not 613. But we're adding up consecutive squares. So the key is to come up with an equation that models it. Now, most people would say that x squared is 1, and you were right. But what are we going to add that to? What's the consecutive square after that?
In parentheses, x plus 1.
Very good. Keaton is absolutely right. Most people do this. They do x squared plus 1. This is incorrect because if x was, say, 10, 10 squared is 100. This would be 101. And 101 is not a perfect square, is it? So notice what Keaton did. Keaton says he is going to take this and do x plus 1, that quantity squared. He noticed that he moved from 2 to 3 and then squared it, 10 to 11 and then squared it. So if you plug in 5 here, you get 5 squared is 25, and then this would produce 6 squared, which is 36. So this is supposed to sum to 613. We got an equation that represents the problem. That's worth 2 points. I need to FOIL or multiply this out. X squared plus, what do you get if you multiply out x plus 1 quantity squared?
X squared plus 2x plus 1.
Thank you. I have a second degree equation. You're ready to complete your college algebra career and receive 3 college credits. Good for you. I'm happy for you. But that means that you have to know how to solve all these equations, and that really needs to be second nature. Okay, so if you got an x squared, that means we get everything equal to 0, right? So we've got a 2x squared plus 2x plus 1 is equal to 612. Or 2x squared plus 2x minus, I'm sorry, I put a 612 over here. Sorry about that. I got ahead of myself. Minus 612 is equal to 0. Sorry about that. If you have a second degree equation, you got 2 ways of solving it. One would be factoring, the other would be quadratic formula. If you want to factor it, go ahead. I would never factor that. I would go to my calculator and I would use the program that Mr. Gentz wrote for me called the quadratic formula. I took time to enter that over my Thanksgiving break when I looked it up on his YouTube page. I have 2, 2, and negative 612. Some of you maybe have it, some of you maybe don't, but if you have it, it produces 17 and negative 18 back quickly. If you do not have that plugged in your calculator yet, I would encourage you to go to my YouTube page and look up quadratic formula. And you should find a 4-minute and 2-second video to program that. Okay. So my two answers here are 17 and negative 18. Are 17 and negative 18 two consecutive squares? Absolutely not. So what do you think I do with 17 and negative 18?
Love them.
You think I do one of them or both of them?
Both of them to see which one.
Yeah. Who knows? Like, let's just try and see what happens. So 17 squared is 289. And then 17 plus 1 is 18. And 18 squared is 324. Those are two consecutive squares that add to 613. Well, what if we would have chosen negative 18 instead? Negative 18 squared is 324. Negative 18 plus 1 is negative 17 squared is 289. I love the beauty of the mathematics, okay? We say consecutive. Did we say the smaller first and then the bigger, or the bigger first and the smaller? The math has a way of finding them in both orders. It really is quite neat. You don't have to write both down. The idea is it's 289 and 324. But, there's two possible ways of getting it, using x as 17 or x as negative 18. It's pretty cool.
289.
So I took 17, I squared it. 17 times 17 is, yep. Good? All right, flip it over. Let's go back to some geometry. A rectangular garden has a perimeter of 288. The length is 4 more than twice the width. What are the dimensions of the garden? Ben, if you just saw this problem, like, I don't know how to do it. What is something you could do?
Probably draw a rectangle.
Draw a rectangle, yeah. I like that. I like that. Good. Yeah. It's talking about width and length, so maybe I could draw like width and length, right? And then we're given this key piece of information, and it says that the length is, in fact, 4 more than twice the width. So this is going to be expressed in a mathematical representation. Length is 4 more than twice the width. 4 more than twice the width. Perimeter and area are not the same. How do we calculate the perimeter of something?
Add them all up.
Add them all up. Sometimes people like to use a formula. They consistently ask me, they say, hey, Mr. Gens, what's the formula for the perimeter of a rectangle? Let's not think about the formula for perimeter of a rectangle. Let's just think about the formula for perimeter of anything. Add it all up, right? So we just do that. So we're going to have W plus, I have 4 plus 2W. So I've gone halfway around. And now I'm going to add up another W, and then I have another 4 plus 2W. And that's equal to apparently 288 feet. Okay. So I'm going to combine my like terms. I have a total of how many W's?
6.
6 of the W's plus 8 is equal to 288. This is not a second degree or third degree equation. This is a basic first degree equation. I'm just going to subtract my 8, divide by my 6. 6W is equal to 280. And so W is equal to 42.3, 46.3?
46.6.
46.6.
46.6. Have I answered the question?
No.
I have a dimension.
Who's dimension?
Dimensions. I need the length as well. How could we find the length?
Add 4.
Yeah, it says the length is 4 more than twice the width. So we're going to double the width and then add 4 to it. So I have 42.6666, and I multiply that by 2, and then I add 4 to it. Well, not 40, I keep saying 42, 46.66, right? Sorry about that. I get 97.3. You good? Okay, so, it's so great. It's right there. His first hour is the same thing, it's just right there, you know? Got Bossy Boss sitting right there with her drink and everything, so, you know. Because we're gonna use that right now. We're gonna use it right now. Can we use it? Can you donate it to the class? Whatever. We're gonna apply it to this thing right here, this next problem, kind of see how it works. Okay, anybody move in the last year, 2 years, 3 years? Anybody move recently to new house?
4 or 5 years ago.
Okay, a few boxes, huh? You know, you can buy boxes at the store that are kind of pre-cut. You go to like the Home Depot, buy boxes that are pre-cut, and then they come like as a flat piece of cardboard, and they're perforating. You like cut them and they shape it a certain size, and then that's your box, right? And a lot of times there won't be a top on the box. So there's a manufacturing process by which we go about this. It's really important. It has a lot to do with this guy right here. We'll show you in a second. So what I'm going to do is I'm going to take a flat piece of cardboard and I'm going to cut a corner out of the side. We're not going to get rid of that corner because we're going to use the corner for some other purpose. For example, suppose that somebody was buying a grill, a really nice grill. We want to like package that grill to make sure that it doesn't get any scratches or anything. So we might use some cardboard to buffer that. So we don't waste anything because we like to make money. Anybody else here like to make money?
I love making money. It's
Yeah.
so much fun.
So we're gonna make so much money, we're gonna be able to give money away, okay? That's the whole point of making a lot of money, right? So here I have this shape all of a sudden, and then all of a sudden we perforate the edges, which means just provide just small little cuts on it. And if we fold them up like so, then all of a sudden we get a shape of a box.
No way.
Okay? And so that's what we're gonna do in this situation, okay? We'll create a box. But as Ledger's moving houses, would you agree that he would like a box that maximizes the volume? Like has the greatest volume so he can fit the most stuff in it? You know what I mean? So that would be a good question, right? Suppose that a company says, we got a bunch of these boxes or a bunch of sheets of cardboard from something. What kind of square should we cut out of it so that we got the most volume, right? Which, she's got this can, I've got a different.
Well,
I like my can better than hers. No, I'm not trying to insult you or anything like that. We're just gonna compare. So anybody else a lover of Mountain Dew?
It's pretty good drink.
It is the most delicious thing on the planet, okay? It is absolutely awesome. Notice the difference in the cans. They're not shaped the same, are they?
They're different.
They are. Which can is better? It's very interesting because these cans, how did the 12-ounce can, how many ounces is yours? 12 as well. They're both 12 ounce. So why one over the other? This can, this is the design that minimizes the amount of aluminum required in order to make the shape and still hold 12 ounces. Her can requires more aluminum. So they spend more money to make this can than that can.
How much more?
Oh, I don't know. But, you know, when you produce it in a massive way, so why would they make this can skinnier? Well, because this is trying to project a healthier option, a skinnier option. You see what I'm saying? So they said, we're going to actually spend more money in order to produce a can, in order to project a better advertising piece. Say this is a healthier option. So people say this isn't healthy for you. I think it's absolutely delicious. Like I've never had one that not felt better afterwards. And Issa, I can see you're leaning into this. You're a lover of the drink, aren't you?
Do the do.
What is the third ingredient listed on there? What's the third ingredient?
yeast and chocolate.
No, that's the second ingredient.
Concentrated orange.
Concentrated orange juice.
Come
Hey,
on.
Healthy choice for the day.
Orange juice.
Drink up, right? Yeah, we ain't making it up. There's, people say, what's in Mountain Dew? Well, it's mostly water, and then there's orange juice, a little bit of syrup. But hey, who doesn't like a little few pancakes every once in a while?
Concentrated.
Yeah, it's concentrated. It's got lots of vitamin C. Let's go.
You gotta concentrate on it.
Yeah. So that's the design. We actually we'll take a calculus problem. We'll actually design the can. We'll go through the process and show them how we come up with that design of the can, those dimensions. And so this problem involves a box, same type of principle, more at a basic level because we're really introducing right now. But a box with a square base and no top is to be made from a piece of cardboard, a square piece of cardboard. I'm going to draw my square piece of cardboard. I don't know the dimensions of the piece of cardboard. I have no idea. But I do know that I cut off these 4-inch corners off the side. And so you can see that I went ahead and tried to show y'all that little demonstration. Hopefully you're slightly entertained.
I was.
Thank you.
You're welcome.
And we cut it, we fold it up and makes a box, right? So I'm going to draw a 3-dimensional box. If you're not good at drawing these things, I'll show you a trick. You just kind of draw the square, and then you just draw another square inside that square, just offset it a little bit to the side, and then you just connect the edges, and all of a sudden you got a nice 3-dimensional shape.
This is third grade stuff.
Lightweight.
Yours is really good.
Thank you, I appreciate it. You take a class in college about how to draw shapes, so.
What? I knew you were. I knew you were lying.
How tall is the box?
Why do you lie to us?
What can we believe?
I can't believe you with anything now.
How high is the box?
You can't
know.
trust
We know exactly how high it is.
No, we don't.
Folks, they,
4 inches.
4, yeah. Because whatever we cut off, that's what we folded up. It's 4 tall. And then its width and its length are going to be the same, but the width and the length, are they the same? Are they X? Are they bigger than X? Or are they smaller than X? How much smaller than X are they?
By 8 inches.
By 8 inches. So this dimension will be X minus 8 by X minus 8. And of course, we all know that volume is computed by multiplying all 3 dimensions together. And so 4 times X minus 8 times X minus 8 is equal to 100. Or in the beauty of this problem, 4 times X minus 8 quantity squared is 100. I need to solve that equation. I recognize that it is a squared, but it's already set up as a perfect square, so it'd be very nice to just divide by 4. And then we take the square root of both sides, and I get X minus 8 is equal to plus or minus 5. And I add the 8 on over, and I get X is equal to 8 plus or minus 5. And so answers of 13 and 3. So now's the important question. Time for you to have that conversation with the one next to you. Are both right? Is one right? Are neither one right? And why? Talk. Go.
Well, let's,
That's what X got.
8.
No way.
If it were, one of them were negative.
then we got 5.
It's 10.
So wait, we need to.
Why is it correct?
Noah, what do you got?
I think they're both correct.
Both correct. Because if you put 13 in, 13 minus 8 is 5, right? And then 5 times 5 is 25 times 4 is 100. You plug in 3, you get 3 minus 8 is negative 5. And negative 5 times negative 5 is 25 times 4 is 100. Can you have a dimension of negative 5 inches?
No.
No. But, and if anybody else finds this cool, please lean into it. This is the stuff I think is so cool. In mathematics, math doesn't understand why couldn't you have a negative dimension? You know what I'm saying? Like, if we talk about things in mathematics, we always talk about like time starting at 0, like a stopwatch, right? But mathematically, why couldn't you go back in time? Well, I guess in reality that's tough, but we have negative numbers in math all the time. Well, same thing about a negative dimension. Why couldn't you have a negative length? And what would that look like? So, the answer is obviously now 13 by 13, but there we go. Right triangle is a hypotenuse. Anybody know my good friend Ella Bordeaux?
I don't think so.
Ella gave me one of my favorite moments in the history of Albert Lee. Ella was taking a psychology class. Anybody else here taking psychology? All right. And when I asked her, and what is this part of the triangle called? She says it is called the hypothalamus.
I don't know what that means.
That's your brain. I said, do you mean hypotenuse? And she's like, what did I say? She said hypothalamus. So anyway, the hypothalamus has a length of 12.5 inches. Ella, if you are watching, you know that we are laughing, and we know that you are too.
Probably heard
And we are not laughing with you, we are laughing at you. It says that one length is X, the other one is 8.5 inches longer. So the other one's going to be X plus 8.5. And it is asking what is the area of the triangle. Remember, it is important to just try anything. Talk to the person next to you, 35 seconds. If you're going to try something, what is something you could try at this point? Go, talk.
Base times height times height.
So X.
So X times, no, X plus 8.5, and all of it over 2. We got X squared plus
So I'd say
8.5X.
Yeah, I heard some people say area is 1/2 base times height. Great, except you don't know the base or the height. So at least I could say good for you. You know that. I could give you a 1/2 point for putting something down. What is another option that could advance this problem? The Pythagorean theorem. Pythagorean theorem connects 3 sides of a right triangle. Let us use that. X squared plus X plus 8.5 squared is equal to 12.5 squared.
That sounds more better than what I have.
So the whole idea is that if we can figure out what X is, then we're going to know the height and the base, and we can use our area formula. In order to figure out X, I need some type of an equation that relates all 3 sides together. And the thing that relates all 3 sides together is A squared plus B squared is C squared.
Oh, okay.
Got it?
Yeah.
Thank you for asking.
No.
Araya just did what we are going to have to do during this unit, which is stop me from time to time and make sure that we explain things if we didn't see it the first time. What do we get if we multiply X plus 8.5 times X plus 8.5?
72.25.
X squared plus what's in the middle?
8.5X.
8.5X plus 8.5X. 17X will be the middle. And then 8.5 squared, Keaton has told us, is 72.25. Thank you. And 12.5 squared is 156.25. Remember, you are elite algebra minds by this point. No equation like this will ever trouble you. You know if it's second degree, you're going to do what?
Square root of 0.
What? Set it equal to 0. X, so 2x squared plus 17x. You subtract the 156.25 over, and you get minus 84 is equal to 0. It does factor, but why not just use that wonderful quadratic formula program that I designed for you on the 4-minute 2-second video on YouTube?
Need that one.
X is equal to 5.5 negative 12.
I'm always behind on everything, guys. I'm sorry.
It's nice. Not all of us can have a nice red python like you, Noah.
Doesn't make a difference.
This Python is quite nice.
You hear that?
Okay,
Python.
3.5 and negative 12. Are they both right? Is one right?
I don't believe the negative 12 is correct.
Can't have the negative dimension, can you? So we're going to choose to use 3.5. I take the 3.5, I put it right here. That's the height of the triangle. And then the length is 3.5 plus 8.5, which is 12. I now have enough information to determine the area. Some people have asked me, do they need to know the formula for area of a triangle on this test? Yeah, I'm not giving you those, okay? Those are ones that if you're expected to know for the ACT, you're expected to know in this class as well. So you do need to know that. Area is equal to 1/2 times 12 times 3.5. You could type in your calculator, or you could say it is 6 times 3.5, which is going to be 21 inches squared. That is my area. You heard word problems. My guess is not too bad yet, right?
No.
Okay, good, good. Okay. We're going to do 2 more before class is over, and then we'll talk about your homework that you can get working with. I love these next 2 problems. I accidentally changed that one to feet. We're just gonna put it all in meters. We're not gonna try to convert back and forth. That's no
These
fun.
shadow ones haunted me as a young student.
Good thing you're not a young student anymore. You can tackle.
You're a big boy.
Hey guys,
Tackle
just think of what Nevaeh said, right?
And
I
she
don't
said,
remember what
We
she
can do difficult
You
things.
can do
We
it.
can do difficult
We did
things if we put our mind to it.
anything is possible.
You're a dandelion. Okay, so I got a lamppost. That lamppost is,
That's a really nice lamppost.
thank you, 6 meters tall. We also go to college to learn how to draw pictures. So.
No, you don't.
Well, what if you're going to artist? What if you're going to artist?
You learned how to
school?
draw a dandelion?
The man is 2 meters tall, okay? And the lamppost is providing a shadow. So I've used this before when cutting down trees. It's something my family likes to do is we like to cut down trees for people. And the question is, how tall is the tree, for example? And how far away do we need to stand from it to make sure it doesn't hit us?
Yep.
Sometimes we make wagers on it and everything, so.
Who's gonna die?
Noah!
So it looks like the light casts a shadow, and the shadow is 5 meters in length. The question in this problem is, what is his distance from the lamppost? One of the most classic examples of using mathematics throughout humanity, and probably the most commonly used application of all. Not necessarily just lamppost, but any type of indirect measurement as we refer to it. You got 35 seconds. You got to try something. What is something you would try? Talk to the person next to you. What is something you would try?
What's the distance?
So-
negative
Squared.
So what we're really trying to
Is
find
it plus or
is
minus 2b?
Will that be given to us?
What's square root of 4? No, b squared plus or minus 4ac minus 4ac divided by 2. Well, that's quadratic formula.
All right, I got a couple people that have said distance formula. Okay,
I don't have to.
Let's do the
we got another thought.
Pythagorean theorem.
A squared plus b squared equals c squared.
Pythagorean theorem.
Pythagorean theorem is a thought. Good. It will not work.
Ah!
But good thought. Way to go. We got 2 good things. Distance formula, Pythagorean theorem, neither one will work. Distance formula and Pythagorean theorem are the same.
They are?
Yeah.
How?
Kira, what's mulling around inside that brain of yours?
I don't know, nothing.
Carter, what's mulling around inside that brain of yours?
Nothing?
Paradise?
Nothing?
Kenzie?
Come on, you guys are elite mathematicians.
My hand hurts.
Dude, you think I got something?
You know what's in my mind?
Why'd you not say it?
Carter, say
I
it.
heard you say this.
Say it now.
What?
Gosh.
Wait, do the.
Wait, I've got 2 triangles. I got 2 triangles that are similar triangles. And you learn in geometry if two triangles are similar, then their sides are proportional. So therefore, what we could say is the height of the man divided by that length is going to be the same as the height of the lamppost divided by its total length. What would we use to express its total length of that bigger triangle?
Or
X,
x.
x minus 5. X minus 5.
Okay, so D is x minus 5.
Uh-huh.
So the entire distance we could also say is D
X plus
plus 5. Yep. Yep, a few ways to represent it. I'm going to use the D plus 5 option. There we go. That's our equation that relates it.
Well, we can cross.
We cross multiply. 2D plus 10 is equal to 30. We subtract the 10. 2D is equal to 20. D is equal to 10 meters. And I should ask myself, does that answer the question? Now, suppose that one of these boys over here said that we'll just use X to represent the whole distance. That would be fine. Then you would have to go back and subtract 5. See what I'm saying? So I came up with D equals 10. Does D represent his distance from the? Yeah, so 10 is fine. If you would have just used X, you would come up with 15, and you would need to subtract. See that?
Yeah.
Yep. So similar triangles is a great option. So I've shown you area, I've shown you Pythagorean theorem, I've shown you similar triangles. We have one more right here is our last problem of the day. I love this problem. One of my favorites in all history. I have two flagpoles. One has a height of 9 feet. The other has a height of 13 feet. Some crazy kid went up and tied a rope from the top of that one down to the base of the other one.
How?
And then some other good climber climbed the 9-foot pole and tied a rope from the top and strung down to the bottom of the other.
So we got two triangles.
They're not as crazy as the guy who climbed the 13-foot pole.
So the question is,
Talking about that.
the question is, how high above the ground? Okay, so I've got like a little bit of grass right here. Okay,
Grassy.
how high above the ground do those two ropes cross?
Oh, is that? Oh, I hate this one.
That's what we're trying to figure
No,
out.
Ledger, you can do it.
So you gotta find where they cross.
They are triangles. This is a third triangle problem. What's interesting about this is that anytime I get a problem, I usually try to solve it about 3 different ways so we can see like what is the most efficient way, and it's just a nice challenge. I've tried multiple ways of solving this. I have come up with more than one. However, this is a similar triangle situation because opposite angles are congruent. And then these angles are the same because they are alternate interior angles. These are the parallel lines cut by a transversal. But I'm going to tell you right now, I don't like that method at all.
Oh.
And in fact, when I went through that method, I didn't like it. So I said, I want a different method. So I chose the other method. And I sent the problem off to like 3 or 4 other people. And every person who did it said, yeah, I didn't like my first method, so I went to this other one. And we all went to the same thing. And this is the last option for what is a great way to try to execute a problem like this. And what I'm going to do is I'm going to kind of change the thought of the problem. And hear me out here. I don't want to lose anybody, okay? I'm going to change the problem with this idea. Instead of thinking about, at what height do those ropes cross, I'm going to think about this as I have 2 lines that are intersecting. I have 2 lines that are intersecting, and I just simply want to find the y-coordinate for where they intersect. That's all I want to do. So let's just slap on a coordinate plane.
Whoa.
This is ground. Oh.
This is groundbreaking.
That may look crazy. That is one of the most excellent methods. I've used it many times in solving challenging math problems, especially with the trigonometry and calculus. It's a great method. You guys can see how this works out. This will be the first problem that really stretches your mind. Okay, we want to get to that on a daily basis a little bit. We can do difficult things. But I have the red line and I have the blue line. So we're going to write an equation for the red line in the form of y equals mx plus b. You guys are doing a great job of leaning in here and just let's continue to look at this, okay? So y equals mx plus b, that red line. On my green axis, b represents the y-intercept. Where does that red line cross the y-axis? 0, right? So I've got 0 for b. So I've got y is equal to something times x plus 0. Now I need the slope, okay? Slope is rise over run. Everybody agreed?
Yeah.
The red line, to go from here to here, how much does it rise?
13.
It rises 13. Does it say how far the flagpoles are apart?
No.
So we'll just have to use a variable d to say that's how far apart they are. So I've got an equation for the first line. So b is the y-intercept. So this line right here crosses the y-axis at 0. Where does the blue line cross the y-axis?
At 9.
At 9. 9 units up, right? So we've got y is equal to something times x plus 9. So now what I need to plug in something for slope. As I go from this spot down here, what's my rise to go from here to here?
-9.
-9. And the run, again, is d. So I've done the difficult part. The rest is really not that bad. It looks foreign to you, but trust me, it's going to work out great. And that's the great thing is when you model a problem correctly. What's that? So do you agree that this spot right here is a value of 9? I have 9 units up. and then this would have a height of 0. So I've gone from 9 to 0, so I've dropped 9.
Oh, okay.
Better?
Yeah.
Okay, so I have two equations, and we want to find the intersection. And we had two methods for doing that, for solving systems. One started with an S, one started with an E. Elimination and substitution. We're going to use substitution here. We know what y is equal to, and we're going to plug it right in there for y.
Oh, so we got
13 over d times x. I'm sorry, that x should not be in the denominator. Kind of looks at there. I got kind of sloppy. Should be right on the edge. Is equal to negative 9 over d times x plus 9. So our goal is to solve for x. So I'm going to gather the x's on the left-hand side. So if I add 9 over dx to both sides, I get 22 over d, x is equal to 9. I want to solve for x. How do I get rid of the 22 over d?
multiply by d.
Multiply by d over 22,
2.
right?
Yeah.
You can multiply by d and then divide by 22. Just multiply by the reciprocal, right? Multiply by d over 22. And so if we do that, we get x is equal to 9d over 22. Now I know you don't like that, and that's okay. And when I first was doing the problem, I didn't like it either, but I trusted that it's going to work out because I know that in terms of finding a coordinate for intersection, I am not looking for the x coordinate, am I?
No.
The question is, how high do they cross? So that's not my final answer. I'm trusting that this is going to make more sense when we get to the y value. Once we get the x value, we find the y value by plugging it in. You have two equations that you can use. I'm going to use the y is equal to 13 over d times x. So y is equal to 13 over d times my x is 9d over 22. And this is where the beautiful thing happens. What do you notice? The d's cancel. They're gone.
They do?
Yeah. What?
And now I get a wonderful number. I get 13 times 9 divided by 22. So on my calculator, I have 13 times 9 divided by 22, and I've got 5.318.
Holy.
So what's really neat about this situation is we know that it is 5.318 feet above the ground. And not only that, but it doesn't matter how far apart the poles are. You can put them 1 foot apart or 1,000,000 feet apart, and this height will remain constant. It will always be 5.318. Yeah. Neat problem. You've seen different methods. You've learned. There's things that you came into class you didn't know, and you now know, which means you're growing more intelligent. So good for you in doing what's difficult. Take out your homework so we can look at it and decide how should we approach these next couple days.
Oh, God.
What does the top of the direction say?
All your work must be completed on a separate sheet of paper.
If you write your answers here, I will not give you credit. This is just the list of problems. Do your work on a separate sheet of paper. In the end, you'll take out those sheets of paper, you'll staple it to your packet as a whole, and you'll hand them in. Okay? I don't want to get, some of you are going to take a half a page for each problem. Some of you will take a sixth of a page for each problem. I don't care. You take your space, outline it how you want, put it all together. But I do not want all of your work written on just this paper. Absolutely not. Okay? All right. Second of all, problems 1 through 12 on the front are right in your wheelhouse. Okay?
Yes.
I would say that they are 95% similar to the problems we've done in class. There's a problem or two that's just slightly different, just a small change. And don't be surprised if you maybe have to ask a question about that at some point, but you should be really good to go. I'm not giving you a question you haven't seen any basis for it at all, okay? But we will continue on next week. Problems will get a little bit more challenging. But coming prepared on Monday with these knocked out might be a really good place to be.
The first page?
First page, 1 through 12, okay? And we're not gonna do all the problems in your packet. There are a few that we're gonna cut out and say, we don't need to do that one, we don't need to do that one. It really just depends on where we get, okay? I will try to get this answer key posted before the end of the day. I did put in your latest test grade into the grade book. That way, you can see where your grade's at and how you want to adjust. Your date, which you would need to retake the test by, is Thursday, the 12th. Thursday, the 12th. I will be here till like 5 o'clock that night, and then I will head home. If you need a study guide from this last test, I need to make more copies. I've got one currently available.
For the next test?
For this test. This past test we just took, I have study guide for the logarithms test.
Oh, yeah.
No, I think it's more than
People have been asking for them, and I just need to make more copies. So if somebody wants this one right here, you can have it. Oh, it's this, oh, I'm sorry. I just can't, my eyes, I just can't read. It goes 1 through 11, 1 through just front page, sorry. Not 12 yet. Thank you, Kira.
Yeah, I should really.